Hi everyone, Assalamualaikum. In this video, we will continue with example 5 under linear equation for first order ODE. Solve the differential equation dy over dx plus y z squared x equals to 2z squared x given y equals to 4 when x equals to 0. Right? From the given question here, we have term containing y to the power of 1. Okay? And there is no term containing y for coefficient of dy over dx and right hand side function here, right? So this is a linear equation. Okay, so we can solve this question using linear equation or integrating factor method, right? Right, to solve linear equation, first step, we write into the form of dy over dx plus pxy equals to qx. Okay, and from the standard form here, coefficient of dy over dx must positive 1. Okay, so from the given question here, we already given coefficient of dy over dx equals to positive 1. Okay, so we can rewrite dy over dx plus we put y at the back here. Okay, so we have plus in bracket z squared x y. Okay, equals to 2z squared x. Okay, so now we can compare from the standard form of linear equation. Okay, we have coefficient of dy over dx equals to positive 1 and then plus px here means term containing x and then y equals to qx means term containing x or not containing y, right? Right, then we can continue with step 2. Okay, identify px and qx. Okay, right, from here, now coefficient of dy over dx equals to positive 1. So we can find px. Okay, when we compare px equals to z squared x. So we can write here. Okay, px equals to z squared x. And when we compare here, qx equals to 2z squared x. Right? After that, we continue with step 3. Find integration of px dx, right? Integration of px dx equals to, we replace px equals to z squared x. So now we have integration of z squared x dx. Okay, we have direct formula for this function. Okay, to integrate z squared x dx, it is equals to tangent x. Okay, plus c, but no need to write plus c because we still not finish our solution. Okay, and then we continue with step 4. Find integrating factor, okay, or IF, which is equals to integration of, which is equals to e to the power of integration of px dx, right? So our IF equals to, using this formula, we have e and then integration of px dx equals to tangent x, right? So we have IF equals to e to the power of tangent x, right? And then step 5. The solution is, we can use this formula. Okay, y times IF equals to integration of qx times IF dx, right? So using this formula, we have y here and then times IF. Okay, IF equals to e to the power of tangent x and then equals to integration of qx. Okay, our qx in step 2 equals to 2z squared x and then time if. Okay, if in step 4 equals to e to the power of tangent x and then dx, right? Right, so we have y e to the power of tangent x equals to, we can move out constant from integration sign. So we have 2 integration of e to the power of tangent x sec squared x dx. Right? From the previous slide, we get ye to the power of tangent x equals to 2 integration of e to the power of tangent x sec squared x dx. Alright, we no need to integrate the function on the left hand side because there is no integration sign. But we need to integrate e to the power of tangent x sec squared x dx because we have integration sign here. Okay, to integrate this function, we can use u substitution. Alright, we choose u equals to tangent x. Then, when we use u substitution, we need to differentiate. We differentiate u with respect to x, so we get du over dx equals to, we differentiate tangent x equals to sec squared x. And after that, we need to write dx as a subject. So we just cross multiply, so we get dx equals to du over sec squared x. After that, we substitute back into this function. Okay, so we have ye to the power of tangent x equals to 2 integration of, we replace tangent x equals to u. And then we still have sec squared x and then times, we replace dx equals to du over sec squared x. Right? And if we choose the correct method and the correct u, we can simplify all terms containing x. So in this case, we can simplify sec squared x here and sec squared in denominator here. Right? And after that, we have ye to the power of tangent x equals to 2 e to the power of u du. Okay? And then, we can integrate e to the power of u du using this formula. If we integrate e to the power of x dx, we get e to the power of x plus c. So now we integrate e to the power of u du. So the answer equals to eu plus c. Right? After that, we replace u equals to tangent x. So we get this. Okay? Then we can write y as a subject. Normally for linear equation, we write y as a subject. So when we write y as a subject, we move e to the power of tangent x to right hand side. When we move e to the power of tangent x to right hand side, means we need to divide each term on the right hand side by e to the power of tangent x. So we have y equals to, we divide 2e to the power of tangent x over e to the power of tangent x. So we get 2 here and then plus c over e to the power of tangent x. But we can write using the properties of indices, we move up. Okay, so we get c e to the power of negative tangent x. Alright. This is our general solution. Okay. Alright. But from the given question here, we have initial condition. Means we need to find the value of C. Okay? To find the value of C, we need to applying the given initial condition. So for this equation, we can name as equation 1. So that it's easy to refer. Right? Right. We continue with step 6. Okay? If the initial condition is not given, this is our final answer. This is called the general solution. Okay? But now, the initial condition is given. So, we need to continue with step 6 to find the value of C. Right? So, step 6, applying the given initial condition to find the value of C after we integrate. Right? So, we need to substitute the initial condition x equals to 0 and y equals to 4 into equation 1. Right? So, we have y equals to 4. So, we substitute here. Y equals to 4 equals to 2 plus c. And then we replace x equals to 0 here. Tangent 0 equals to 0. Okay. So we have e to the power of 0. We no need to put negative because 0 is not positive or negative. Okay, we just put 0 here. Okay. And then e to the power of 0 equals to 1. Okay. So we get c here. We move 2 to left hand side here. So we get c equals to 2. Right? 4 minus 2 equals to 2. Okay. After we find the value of c, we need to substitute back into equation 1. Okay. Into the general solution. So the particular solution is y equals to 2 plus 2e to the power of negative tangent x. Okay, this is the final answer. Okay, we replace c equals to 0 into equation 1 here. Okay, so we get 2 here. Okay, that's why the final answer is y equals to 2 plus 2e to the power of negative tangent x. Right? This is the particular solution and this is the general solution. Okay. Up to this point, we done discuss three methods to solve first order ODE, which is variable equation, homogeneous equation, and linear equation. Coming up next, applications of first order ODE. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.